our practice, we're going to draw a couple of angles here, and we're going to draw them in standard position. So standard position means that your first angle is lined up with the x-axis. So here we go. Here's x, here's y. Okay. Now an angle is just the joining of two rays with a common vertex, right? So here's my initial ray. And if I'm drawing an angle in standard position, my initial ray needs to be lined up exactly on the x-axis, like parallel to it. And then 45 degrees, that we know, is exactly splits 90 degrees in half. So a 45-degree angle looks like this at 45 degrees. And this ray, the second ray, is called my terminal side. So I have an initial side, the first ray, a terminal side, the second ray, and the space in between is what we've wedged out called a 45-degree angle, all right, or an angle. So a thing to note here is that positive angles, here's the symbol for angles, right, move counterclockwise. Positive angles move counterclockwise, so and they move in this direction against the clock, counterclockwise. Does that make sense? Okay, so there's a 45-degree angle. Okay, use your protractor there and draw a 1. Okay, so yours should look something like what mine does in part B there, right? It terminates in quadrant 2. This is my initial side over here. This is my terminal side, and then the space between the angle makes 125 degrees of an angle. Does that make sense so far? Okay, so now let's talk about negative angles then. So if positive angles move counterclockwise, then what does that mean negative angles move? They move clockwise, right? So if I have a negative 30-degree angle, okay, I'm going to start off with my initial side lined up with the x-axis here. And then I'm going to go 30 degrees in the clockwise direction down, so it would look something like this right here. This is a negative 30-degree angle. So notice negative 30 degrees puts me into quadrant 4, because this is quadrant 1, this is quadrant 2, quadrant 3 again. Yeah, there's overlap. You guys hit it right on the head, right? So you would think that there's only there's only 360 degrees in a circle, when in fact, right, you can go all the way around. So since 405 degrees is the same thing as 360 degrees plus 45 degrees, what we're going to do is we're going to take our angle, we're going to go all the way around once, 360 degrees, and then we're going to go up 45 degrees. And you get this cool little spiral thing that's happening. Yeah, kind of strange. So there's my initial side there. And then my terminal side looks, what happened there? So the next thing we have to talk about are some important symbols that we use for angles in trigonometry. And this book in particular uses the first one and the last one. So all you physics people out there, right? On the left-hand side here, I've highlighted some of them for you. We're going to use theta a lot. We're going to use, is this gamma, right? Gamma, beta, and then alpha. So whenever we're talking about angles, these 4 symbols are generally reserved for the ones that we do talk about in trig class. But the book usually uses theta and alpha, the top one and the bottom one. But all the other ones could also be used. So think of it as like a variable, you know. They'd be like the sine of theta or the sine of alpha. So they're talking about some angle in there, okay? Okay, the next big idea for us is to talk about degrees, minutes, and seconds. Have you ever heard this before? No? Here? Really, really tiny stuff, okay? So our first goal then is to understand, well, how do we just define these things? So like I just did with my hands there, 1 degree is equal to, 1 minute is equal to 1/60th of a degree. A minute is equal to a 60th of a degree. And 1 second is equal to 1/3600th of a degree. So tiny, tiny, tiny space. Okay, so the first skill that we really need, all this is are just skills that we're doing, basic skills here. So we're going to take 50 degrees, 6 minutes, 21 seconds, and turn it into a decimal. 50 degrees, 6 minutes, 21 seconds, turn it into a decimal. Okay, so my question to you is, between which two whole degrees does this decimal lie? Between which ones? 50 and 51. This angle is somewhere between 50 and 51. Do you guys agree with that? Right? And we're talking about a degree of accuracy, like a really tiny space. So this is somewhere between 50 and 51. So our decimal should be 50 point blah, blah, blah. And our goal is to find the blah, 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 right? Okay, so here's what we're going to do. Well, we already know there's a full 50 degrees in here, right? So my answer is going to have 50 point and then something in the end. So what I'm going to do is I've been given 6 minutes. And since 6 minutes is 1/60th, right? I take 6 times 1/60th, and that will give me the decimal for how many full minutes are in there. So could you tell me what would that be? I'm multiplying the minutes part, 6 minutes, by my conversion factor of 1/60th. Because I've been given 6 full minutes in there in my angle, so I'm multiplying it by a 60th. So what would you get? Yeah, 0.1, okay? Okay, then I'm going to take my seconds, which is 21, and I'm going to multiply that by 1/3600. And that should give me another answer. So what would that be? 0.0058, is that right? Oh, 0.058. Okay, thanks for helping me out. 0.058. Now I got 0.0058. 21 times 1/3600. Is that right? Can someone verify that, please? Yeah, okay. So now, right, what we do is we add this all up, right? We take the 50 plus the 0.01 plus the 0.0058. So an answer should be 50.01058. No, shoot, sorry. 50.1058. There we go. Okay? So, and that is a degree. So again, that's somewhere between 50 and 51, right? Which is what we knew. So we can convert between the two, all right? Going the other way is a little bit more tricky. So we're going to take 21.256 degrees, and we're going to change that into degrees, minutes, and seconds. Okay, so again, we ask ourselves, well, where is this angle? This angle is somewhere between 21 and 22 degrees, right? So I know that I'm going to start off with a full 21 degrees, aren't I? I know I have that many full degrees. So then I'm going to focus my attention on the leftover piece, right? So in the leftover piece, I'm going to break this up into minutes and seconds. So I'm going to take 0.256 and multiply by 60 to sort of release the minutes here. So 0.256 times 60. Somebody help me out. What do you get? 15.36. So my question to you is, how many full minutes? 15. So this gives me the 15 minutes. You guys with me? Okay. Now then, how do I get to the seconds? Well, I take the 0.36 and I multiply that by 60. Now, some people would think it should be 3,600, but you have to remember, we already got the 0.36 by multiplying it by a 60 in the first place. So if we did it again, we'd be overstepping our bounds, right? So we go again by another 60, and what would that give us? This will give me 21.6. So this is a full 21 point, if you want to go 0.6 seconds, right? So there we go. Now, the book might round that up to 22 seconds. Not exactly sure what they want, but let me give you a demonstration on the calculator and how we can do that second one, okay? File, new, and we'll hit OK, and we'll hit play. I'll put you away. Okay, so I'm going to show you how to do the second one. So we're going to take 0.256, and we're going to multiply. We're going to change that into degrees, minutes, and seconds. So here's how you do it. Oh, thanks. There we go. Okay, we're going to hit second, and then we're going to hit apps. Second apps brings up the angle menu, and you can see you have a variety of options, right? The first one is a degree. Second one is a minute. R is, I'm not sure what that one's for, radius maybe. But this one down here, DMS, that stands for degrees, minutes, and seconds. So push enter again, bam, there it is. 21 degrees, 15 minutes, 21.6 seconds. Pretty cool, right? You have the ability to do that now. Okay? So you gotta have the skill and you gotta have the tool. All right, the skill is what I just showed you, and the tool is. Okay, there are two ways that we use in mathematics to measure angles. One of these ways is called a degree. And you know what? We're pretty good at that. Would you guys agree with the degree? The second way is the radian. So that's going to be our focus. What the heck is a radian? Okay. It's actually a much more natural way to measure an angle. Let me give you a little demonstration. You do not have to write the circle part down. Okay? Let me give you a demonstration here. So I have two circles. Would you agree with my two circles here? And they're different sizes, right? So that means they have different radius. So I'll call this one radius 1. I'll call this one radius 2. You okay with that part? Okay, so if I took my radius 1 and I took the same length of radius 1 and I put it vertically and perpendicular to my circle. Okay, now here's the abstract part. Think of it as like a wet noodle. Think of it as if you were to bend the radius back onto the curve of the circle, you would cover in blue about that much. Would you guys agree with that? I mean, my cheesy little sketch, would you agree it's about that? Yeah? Now, if I were to draw an angle and make an angle out of that, that would be 1 radian. How easy was that? Now check it out. Let's do this same demonstration with R2. Same thing, there's R2, about that right now. Use your imagination, bend it back on, and I would cover about that. Would you guys agree? And check it out. Oh my God, it's the exact same angle. So a radian has nothing to do with the radius of a circle, right? The angle is totally independent. And it doesn't seem like that should work, but it totally does. So if you think about this, okay, here's a couple of things that we should write down. How far around the circle? What do we call that word? Circumference. And is there a formula you learned in geometry for circumference? Nope. That's area. Nope. What is it? 2 pi. There you go. Okay, so the circumference of any circle is 2 pi r, correct? Yeah, they're like, where am I going with this, right? Okay, and then how many degrees in a full circle? 360 degrees is equal into a full circle, right? Now, I just told you that the radius is independent of the angle, right? So we might as well just call the radius 1 for now to discover a few things. So that means 360 degrees is equal to 2 pi, and that is our first relationship that we have. If you go all the way around the circle, you have gone a measure of 360 degrees. If you've gone all the way around the circle, you also have gone a measure of 2 pi radians. Okay? So, the equivalent thing that we need to know is that 360 degrees is the same thing as 2 pi radians. That's just the name of it. Okay? So now a couple of neat things happen. What if I divide both of this box that I have here, I'll highlight for you. If I divide both sides by 2, what do I get? 180 degrees is equal to how many radians? Pi radians. So when you're talking about 180 degrees, you're also talking about pi radians. So let me ask you a question. What's bigger, 1 radian or 1 degree? 1 radian is much bigger. Look, that's right here. Right? Here it is. This is 1 radian. It's bigger. Okay, now if I divide both sides of my box that I have here in blue by pi, what do I get? No. No. If I divide both sides by pi, what do I get? 1 radian. What? 1 radian is equal to... what is wrong with this? Come on. Junior Racer. There we go. 180 over pi degrees. And that is our conversion factor for radians to degrees. And then I think Olivia just said that this was about, how much was it? So 295. If we round up to one decimal place, that would be 57.3. Do you agree? Hey, doesn't this angle look to be about 57.3 degrees? And doesn't that angle look to be about 57.3 degrees? I mean, if I had to guesstimate, I'd say about 60, right? With the way I did it, but that's pretty darn close. So we now know that 1 radian is 180 over pi degrees. Okay, I need one more special conversion factor, and this one will be in green for us right there. If I go back to my blue box, if I divide both sides by 180, what would I get? 1 degree would be what? If I divide both sides, there you go, pi over 180 radians. Okay, and then that will be in pink. Can you guys still see that? Not at all. That's amazing. Sorry about that. We'll go back to yellow. Okay, here we go. And again, this is just another skill that we have to have in trig. So not a lot of deep thinking, just top of the head knowledge for today. Okay, let's convert from 30 degrees into radians. Okay. So what we're going to do is we're going to take our 30 degrees. We're going to multiply by our conversion factor of, let's take it out, what was it? Let's see here. 1 degree is pi over 180 radians, so I need to multiply by pi over 180. That gives me 30 pi over 180, which of course is just 3 pi over 18, which is just pi over 6. So there we go. 30 degrees is the same thing as pi over 6 radians. Nope, you leave it in exact form, pi over 6. That's what we're going to be working with a lot. Okay, can you guys do negative 4? Negative pi over 4. Yeah, you're right. So for this one, we would take negative 45, and we multiply by pi over 180, which is just negative 45 pi over 180, which simplifies to negative pi over 4. So now we have this relationship of 45 degrees is pi over 4. By the way, there is a great table on page 502 that you should probably look at in your book. There's a great table on page 502. You should check it out. Okay, now let's go the other way. All right, let's take a radian and turn it into a degree. So if I've got 3 pi over 2, I'm going to multiply by 180 over pi. Notice that it's the reciprocal of what we were using before. Okay, one neat thing when you take the exact value is that the pi's, of course, cancel out. And this leaves me with 3 times 90, which is just 270 degrees, because the 180 over 2 becomes 90, right? So there I go. I got 3 pi over 2 is the same thing as 270 degrees. Okay? Okay, you should have got 420 degrees. You guys get it? Yeah. Okay, so again, right, we can go past 2 pi, right, because obviously 7 pi over 3 is bigger than 2 pi. So we can actually go past it in radians just like we can go past a full 360 in degrees. Okay, last idea. You do not need to write down the wording here. You can just follow along, but you got to be able to solve this problem because there's one of them just like that in your homework, so I want to go over it with you, okay? It's the clock problem. It's a great clock problem. And it also covers the arc length theorem, which is our first important theorem that we have dealing with trigonometry. Okay, here's what it says. It says, if the minute hand of a clock is 8 inches long, how far does the actual tip of the minute hand move in... Okay, so here's a little picture, right? And I'm only drawing the minute hand. I'm not drawing the hour hand, right? In 15 minutes, where's that minute hand going to be? It's going to be on the 3. We all agree, right? So oh, you're going crazy, aren't you? Okay, let's try to find. Okay, so what is so different about this versus any other distance that we've tried to find in the past? It's curved, right? It's curvy, right? So how do you measure a curved distance in length, right? Well, you have to use this arc length theorem, okay? And the arc length theorem says this: S, which is the distance covered by this red line here, is equal to the radius multiplied by my angle theta. That's it. And you wouldn't think it's that easy, right? But the trick is this. Theta must be in radians. So we have our first theorem involving our new way of measuring an angle. Theta has to be in radians, okay? So for us, our arc length, which is, again, this is the distance that's been swept out by that. That's what we're trying to measure, that distance. Also, think of a bicycle tire, right? If your pump is right on the floor, how far does that tire have to travel before the pump part gets right back to the floor again? Same idea, right, versus tires, okay? So the radius matters and the angle matters. Okay, so what do we need? We need a few things, don't we? So S is equal to R times theta. So S is my radius, which I happen to know is 8 inches. But what's the thing that I don't know? What angle is that, right? Well, this is an easy one because that's a right angle, isn't it? So if I take 90 degrees and I multiply by pi over 180 to change it into a radian, that's just pi over 2, huh? So now I can dump pi over 2 into my formula. So that distance has to be 4 pi or 12.56 inches total. Okay, so that's what we need. So we need to figure out, well, what is this angle in here called theta? That's what we need. So again, we know S is R times theta. So S is going to be 8 inches times my theta, which I need to figure out. So how can we figure out what angle that is? It's 210. Yes, how'd you get that? There you go. Okay. So you could also do 360 degrees total, multiply that by 7/12, right? Because it looks like a 17. Because there's 7 out of 12, and that also gives you 210 degrees. Okay, now I need to take my degree and I need to multiply it by what? By pi over 180, and that just gives me 21 pi over 18. So now I can take that answer and dump it into my formula, 21 pi over 18. So my S is approximately 29.32 inches. That's how long that distance